This is the review for the Bernoulli distributions quiz. And you're probably going, wait, what are Bernoulli distributions? I don't remember you saying that. Well, I did in the notes. But Bernoulli distributions means you have a probability of success or failure only. And your probability P is a number, and it doesn't change, all right? Each trial is independent of the other. So let me and if it's geometric, you're looking for the probability of first success. And if it is binomial, you're looking for the probability of X successes out of N trials. So this N right here is super important, all right? Because if you know that, then let me see if I can do it again. There we go. Lets me do red in there. Yes, yay. So X successes out of N trials, that's important, okay? Whereas this is just the probability of first success. Okay, and if you're looking for formulas, you're mainly going to have to focus on binomial distributions, okay? That tends to be the one that we are working on in AP Stats. Geometric distributions used to be a little bit more emphasized, but those are going to be phased out in the future, not necessarily this year. And but the formula is pretty intuitive, and you can find it on the formula chart. So when you're taking today's quiz, make sure that you know the two formulas. So I actually probably can show you the formula for, well, actually what I'll do is I'll show you how this gets filled in for one of the examples. All right, so when it's appropriate. So looking here, actually, you know what? I'm going to do this as an example. That's fine. We're fine. So let's go ahead and go to our first problem. Then I'm going to go ahead and go to the other side, partner B. And was there anything? Yeah. There we go. Okay. So let's start at the beginning. We're doing geometric again. So let's just make sure we're really just going to double check our answers, doing it the same way you did here. Again, this is first male diagnosed. So we know it's geometric. All right. And it's Geomet PDF right there. Okay. So you can use the formula, or you can tell me what distribution. P equals 0.03. And then you just go probability that, tell me what distribution first. Probability X equals 20 is 0.0168. So let me go ahead and show you how that works. Let me do that so you can read it a little better. And my little dot can, well, I'll erase that. There we go. So make sure that you're getting the right distribution. So you can use the formula to show your work. It's great. I'll show you how to use the formula over on the, well, it's kind of hard on here because I don't have the notation. I could write it by hand. I might add it in. But you can also, well, there we go. So let's go ahead and do geometric. So we're going to do second distribution, geometric. I'm going to go backwards. Oh, there it is. Geometric, it really is faster to come from the bottom. We're doing PDF because we're doing an exact value. Now we're 0.03, and our number of trials says, well, we're not doing trials yet. And we want to know the probability of the first one diagnosis, the 20th person. And then, boom, 0.0168. All right. If you're doing the number works, we got to change distributions. Go to geometric. Okay. And our probability is 0.03. And we want probability that we want a discrete line. So this is like PDF on the numworks. And we want that to be the 20th person. And there you go. And again, it's not available on the Statlet. They just expect you to kind of use the formula, which I guess they were kind of prescient because it's like, well, if you look, there is no geometric distribution on here. And it's kind of going away. So maybe that was a hint from Statlet. You don't really need it. And again, don't forget you have your formulas here. I'm going to go ahead and show this on the next problem. So if you're doing binomial, remember the other way, if you show the formula and you have the formulas in front of you on the chart, okay? So you could, let me go ahead, there we go. You could put the N and the P. So for this one, I'm going to use this one for partner B. N is, I keep wanting to go to my other tools. In this case, N is 500 and X is 20, right? Let's 10. X is 10. All right. So let me write down X is 10. So what would this look like? Well, let me show you on the calculator. It's probably easier to do it on the calculator to show you. All right. So if I was doing this, the way I'd go, let me go home and hit calculations. The reason I'm doing it on this calculator instead of the other one is it actually shows the formulas a little bit better. So we actually have, let me see if I can do it this way. Actually, I'm going to do, yes. So we have, it should be counting probability. There we go, probability. And then you go, I hit the toolbox is what I hit. Now you're normally not going to have to do this. See, look, it matches the formula. It's a combination. So I just put in, the first number is N and the second number is 10. All right. Then we go times, it's going to be your P, 1 minus P, minus 0.06. So you're going to have, actually, I think they did P first. We're going to do it in the right order. So it's going to be your P. So how many times does P have to occur? Here, I'm going to temporarily move this over here so you can see what's going on. All right, so I'm doing that formula. So I'm doing P, and I hit the upper arrow to go up, to the X. So we have 10 successes, all right, times, and then you have 1 minus P to the N minus X. I'm going to do parentheses there just to be safe. In this case, it's 10. And then you hit enter. Oops, let's see, did I do that right? I think it thought the X's. All right, let's try that again. It doesn't like the X's, so let's just do it. It's probably saying, oh, you can do this much easier. So we're going to do that again. 510.06 to the 10 times. I think I had an X instead of a. I hit the X on my keyboard. That's why it didn't work. Oop. Go up. And the way you can go up is the up arrow, by the way. So this is one way you could show this on the calculator. All right. So 500, let's see, 10, yes. I'm getting a very small number. So I did N minus X. I haven't done this in a while, so I'm just double checking. All right, so let's go see if we get a very small number on this one. Okay, back to our problem. Oh, let me put my calculator back where it was. Probability exactly 10. 1 minus 500. It should work. Okay, maybe I'm like, oh, it's not behaving. So let's go back to our probability distribution, which is way easier. This is why you probably shouldn't use the calculator. It's like, why isn't it working? Pretty sure that's wrong. Okay, so we need to go out of the geometric and go to binomial. Hit OK. Put 500 trials. Point. Oh, I know why. I have 0.06 in there. It's supposed to be 0.03. That's why it didn't work. Let me go back to my calculations. That's why I wasn't getting the number. I have the wrong number. Let's try that again. So we'll hit the little toolbar, go down to probability. Mrs. Everman's stubborn. Combinatorics. Helps if you have the right one. 500. Yeah, because I was thinking of the last problem. It's 0.03 times 0.03 to the 10th, come down times 1 minus 0.03 to the, got to go in the exponent, 500 minus 10. There we go. Ah, did I do something wrong again? Maybe we should, I know what I did. I put 0.03 in the thingy. Okay, so let's try to hit that little toolbar. You guys are getting tired of this, sorry. 500. Well, hey, I'm just demonstrating all the ways you can mess up on doing the formula, which is why we don't tend to do it. It is easy to, there we go. And then go up 500. So make sure all those numbers match. You can see I goofed and I put the 0.03 in the formula. There we go. That matches our actual answer. It helps when you use the numbers in the problem. So, moral of the story, use the easy things. Go ahead and use the distributions. Do not calculate things by hand. If you don't, I coach calculator and I still make boo-boos. So I'm much better at these distributions, though. All right, and let's make sure that's right. P, 0.03. And we want exactly, so we're going to come here. Instead of typing in that horrible formula, we're going to do that. And we're going to change this to 20. And boom, there's the answer. Well, let's see, we said, not 20, 10. There we go. Now I have the right answer. So make sure you put in the right values, okay? And that first person being the 20 threw me off. And of course, last but not least, you're going, but Mrs. Overman, I'm using a TI, so let's go use a TI. We're doing binomial PDF. Make sure you do the exact. There you go. All those answers match. All right. Okay, then let's scroll on down, and we're going to do number 3 now. So, yeah, you saw the formula. It was kind of a pain. Be careful with it. Okay, what is the probability at most 10 are colorblind? So CDF is at most. Okay, let me make a note. CDF is at most. So you don't have to do anything fancy. You can just go ahead and work it. By the way, when you're taking your quiz, I might change the order of these because I don't want you just running through. I want you thinking about which one's the right one to do. So let's go distribution. Now, instead of PDF, we're doing CDF. Again, make sure you're putting these numbers in correctly. It's very easy to make mistakes. And boom, 0.11478. That matches what I had. And here I already had, let's do at most. So let's make sure we come back here. Do at most. And change that to 10. Same answer. And then if you go to the Staplet, because you don't have your own cool NumWorks calculator, make sure you have 500, 0.03, plot the distribution. And the nice part here is you get to actually pick the word. At most 10. I keep wanting to put 20 in. Very strange. All right, next, what is probability less than? So the nice part on this one is you can just say less than, and there you go. And it gives you a slightly different number, right? Now, it's very hard because our sample size is so big to see the shift there, but this is the box that we're looking at right here, okay? And it got a teensy bit smaller. So if you're doing less than on the NumWorks, you just do the adjustment here because there's no less than option. It's less than or equal to. So less than 10, what's the biggest number less than or equal to 10? I mean, less than 10 is 9, and there's your answer, all right? If you're doing the calculator, you have to go get the distribution again. Now, you do see that you're having to get the distribution every time. So it's kind of annoying. But on the bright side, it keeps these numbers the same. Boom. And there you go. There's the answer. All right. What is the probability at least 10 are colorblind? So what we have to do, if you were to write the sample space, all right, let me go ahead and do that. So we want our sample space. Let me go ahead and we can have 0, 1, 2, 3, 4. So this keeps going all the way to 500. All right. So we want at least 10. So the reason is, why am I drawing this? The reason I'm drawing this is primarily for the TI people. All right. Because it doesn't have an at least 10. So let me move this here. There is no at least 10. So you have to figure out what's going on. Well, at least 10, what we're looking for, our answer is over. I'm going to color it purple because we're the raters. We want 10 and higher, right? So that means we don't want 9 and lower. So if you're using a TI, you can basically say, this is acceptable work. This actually what you had here, especially since you already calculated it, you could just say equals 1 minus binom CDF, n equals 500, p equals 0.03, and x equals 9. All right. And that will give you the same answer. Now, the other work you could do, or you could say, if you're doing like a numworks or a Staplet, tell me the distribution, tell me n, tell me p, and then give me what you're looking for. X is greater than or equal to 10. You don't have to do the 9 adjustment for the other technologies. All right. So you can pretty much do that there, and you can see, let's go ahead and do it. So if I was doing Staplet, these are the other technologies. We're going to say at least 10. Yeah, at least 10. And you can see my answer was 0.9331. Here, the calculator, so the numworks, the other side is the at least side. So let's go here. Change that to 10. There you go. And you get the same answer. Okay. And then we have 12 sets of experimental goggles that may help. What is the probability we have enough? So that means we want at most. So that we want the probability that we don't run out means we use at most 12 sets of these goggles. All right. And you can see it's 26.38. If you're doing the binomial distribution, use at most 10. There they are. Oh, 12 sets of goggles, not 10. There you go. That matches. And if you use a TI, second distribution, binom CDF, we're doing 12 goggles. So the only thing that changes is 12. Well, make sure it says 12. There we go. And we have the same answer.